Hello differential equation students. So let's take a look at how do we solve Bernoulli's differential equation. So what is a Bernoulli's differential equation? So this is very similar to the previous linear first order differential equations, except that this is non-linear. So if you recollect our linear differential equations, first order linear differential equations, which had the form of y prime plus p of x times y is equal to q of x. This is linear, but the issue here is, so this was the power was 1, that's linear. This is also linear, so it was linear. But the issue here is, here you see this one right there, this one right there is actually non-linear, as you see things there. So this is a non-linear term. So how do we work with this non-linear term? So anyway, before I go any further, again, anything which is of this form is what we call the Bernoulli's differential equation. The way that we're going to solve is very similar to what we did over there, except that we're going to use some sort of a substitution method, right? Either we can use the substitution method or we can use the substitution method, but I'm going to choose this one to do that. So how does this substitution method works? This is how it works. So there's like 4 processes or 4 boxes. I'm going to do the 4 boxes. Number one is that you have a differential equation y in terms of x, right? So you have a non-linear, I'm going to say non-linear differential equations, first order differential equation y in terms of x, right? So let's bring it down here a little bit. Let's box it up. And then what you're going to do, you're going to do some sort of a substitution. You're going to do some sort of a substitution in here. And then what you're going to do is, you're going to do the substitution. That substitution is either you're going to use, u is equal to y to the 1 minus n. That's not n minus 1, by the way, that's a 1 minus n. Or you can do this substitution, which is u is equal to y to the 1 minus n over 1 minus n. This is what I like, that's what I'm going to use, right? So when you do this substitution, then what's going to happen is that you're going to have a new differential equation, and that differential equation is going to be a linear first order differential equation, but that is going to be u in terms of x, not u in terms of not y in terms of x. Now we're going to have u in terms of x. So then we have this differential equation that we have to work with. So let's make this one bigger, right? Then you have this one right there. Then what do? You're going to solve this, right? Then what you're going to solve this. When you solve this, again, we're going to use the same method that we used previously. So we're going to use the same method that we have used, in the previous in the previous steps, right? We're going to use the same method. And by the way, I think I had a 0 before. Let me change it to q of x. That is supposed to be q of x. And also this is homogeneous. That's okay, right? This should be q of x, and also this should be q of x as well. I think I had a 0 there. Anyway, so we're going to use the same method in here. We're going to use that same exact method in here. And once you do that method, we're going to solve, and then we're going to have a differential equation, which is going to be, we're going to have a solution, right? And that solution is going to be u of x, right? We have the solution u of x, right? And now what we are going to do afterwards is that we are going to so we solve this, right? And then we are going to do resubstitution. When we do the resubstitution, right, again the same thing that we did before, we're going to convert this u in terms of y. Then we're going to have a solution y of x, and that is the solution to this original differential equation. So that is how we get the solution to this differential equation. So right? That's how we get the solution to the equation. So this is the process that we're going to follow. I will show you how this process is going to work in a moment, but that's the general process that we're going to work with this one in solving this Bernoulli's differential equation. So what is the process that we're going to work together to get that? These are all very similar, right? The step one is what you're going to do is you're going to make sure the differential equation is in the Bernoulli's one. If it's not already in there, you need to turn this or transform this into y prime plus p of x times y is equal to f of x to the y to the n. That's a step number one. The step number two is basically what you're going to do is you're going to do the substitution, and that's I'm going to call this as p tilde. You'll know in a moment why that is. You're going to have then substitute u is equal to, I'm going to use this y to the 1 minus n over 1 minus n. When I do that, what's going to happen is that you're going to have your u prime. Remember, u is a function of x, right? U is a function of y, and y is a function of x. So therefore, when we say u prime, by which we mean du over dx, that would, by the chain rule, this will be du with respect to dy and then dy with respect to dx, right? So this is going to be du with respect to dy times dy with respect to dx, right? That's what the chain rule is. So we will use that kind of a chain rule over there. All right, now if I do that, then you see what's going to happen here is your u prime is going to be 1 minus n to the y to the 1 minus n minus 1 divided by 1 minus n, and this 1 minus n 1 minus n is cancelled, and by the way times the du over dy over dx, then that is going to be your y prime. So if I simplify this, then the simplification would be nicely turn this into something like that, right? That's the u prime. So we're going to use it again there. And the step 3 is going to be now we are going to rewrite this. Then you're going to have using this, when we do this, what's going to happen is that now you're going to have a new differential equation. Now you're going to have a linear differential equation, and that differential equation you need to rewrite them in the standard form, which is u prime plus p of x times u is equal to q of x, and follow the previous method we did earlier and then solve using the previous method. So we're going to solve using first order linear differential equation, what I call fold-A, right? Using first order linear differential equation or integrating factor method, or integrating factor method. Then what you do is that and the next step, so let's call this the step 4. The step 5 is now you have a solution, right? Now you're going to have a solution u in terms of x, but I don't want that. I want the solution y in terms of x. So to do that, what I am going to do, I am going to now then transform, right, or resubstitute. I am going to resubstitute, and then that is going to give me solution y in terms of x. Sometimes it's easy to do, sometimes you may have to leave it in terms of implicit form or some sort of a curve form, and that's okay. If you cannot solve for y perfectly, that's all right. So just do your best to solve it, and that is the idea behind doing this. Let me execute this process for this particular problem that we have right here, right? All right, let's take a look. How do we solve that? So step number 1, so this is not already in that form. So what I'm going to do is I'm going to first transform this into the standard Bernoulli's form. To do that, I'm going to divide both sides, the entire equation, by x. If I do that, I am going to have y prime plus 1 over x times y equals 6x squared y squared divided by x. and I can cancel the x and x, so I will be left with simply 6xy squared, right? So if I erase this and then if I move this one over here, that's what I would have right there. All right, now again if I go back in here, this is what we call the n, right? That's the number is called the n, and that is the n that we are going to use it right here. That is the n that we are going to use it right here, right? So let's do that. So let's do the second step. To do the second step, I should know my n. As I just said, the n right here is going to be this guy right there. So therefore n is equal to 2. So therefore my substitution that I'm going to use is going to be u is equal to y to the 1 minus n over 1 minus n, and here my n is equal to 2, and so therefore I'm going to say this is 2 minus 2, which is going to be y to the negative 1 over negative 1, which is negative y to the negative 1. And then let me try to figure out my u prime. If I try to figure out my u prime, as you all know, this would be negative times negative is positive, y to the negative 2 by the chain rule times the y prime, right? All right. And what do we have? The step 3 is now we are going to do the substitution method. We're going to do the substitution, and let's see what happens to that. I'm going to take a look at these two information, that u is equal to y to the negative 1, u prime is equal to y to the negative 2 times the y prime. I'm going to plug all these information back into this, right? I'm going to plug this back in here. When I do that, what's going to happen? The following is going to happen. So I'm going to rewrite in a different color so you can kind of follow this along. Or actually, as a matter of fact, sorry, I'm going to plug this back into this guy right here. When I do that, what's going to happen here is, now y prime is going to be, as you see here, u prime. Oh, I'm sorry. I am supposed to do one more step, right? I'm supposed to do one more step to make my life easy. Let me do the one more step. What I'm going to do, I'm going to divide this equation. I'm going to divide this equation by y squared first. When I divide that by y squared, I am going to have y to the negative 2 times y prime plus 1 over x times y to the negative 1, because if you really see what I'm going to have y over y squared, but then y over y squared is same as saying y to the negative 1, right? So that's why I don't need to have that. And then what I'm going to have is, then I'm going to have on the other side is I'm going to have simply 6x, right? And now it's easier for me to transform. Again, this is still a part of the transformation process. Now, if you really pay attention here, ladies and gentlemen, this right here is exactly that right there. So therefore, the very first term, now do you see why I did the transfer, why I did this step now, right? So that's your u prime, as you see in there, right? And if you take a look at this right here, y to the negative 1, right? It's this, but not exactly this. There's a negative in here, but that's okay. We can handle it, right? There's negative in there. It's not a big deal. We can handle it. So let me change the color so you can see it better. I'm going to change this color to maybe purple. And so this is also purple, as you see. All right. And I'm going to change this, not exactly. I'm going to change that into, oh no, I'm going to change that into, let's just say orange. And you see that there is also right here, which I'm going to use, not exactly, there is negative in there, but that's okay. We can work with that and the orange there, right? So now I have, this is my u prime and here is my, u prime. Here is my u prime plus, and then I have my 1 over x, and then I have my this y to the negative 1, but this is not really u, that's actually minus u, and that's okay. We can work with that. Minus u right? Now that is equal to 6x. Now it's all, we're not there, but we're almost there, right? Now if I simplify this, ladies and gentlemen, what I'm going to have is I'm going to have u prime minus 1 over x u is equal to 6x. Now that is the linear differential equations, first order linear differential equation. So right now we are right here, right? That is in that particular form. Now you see why I changed this to, you know, change the previous to p tilde, because initially our p of x is 1 plus 1 over x, right? Plus 1 over x, that's what we call it as, you know, p tilde. But as a matter of fact, the p of x that what we have here is actually negative. So that's why, you know, I don't want to confuse. So that's why I use the p tilde for that. Now, so therefore, that's we know how to solve that. Let's quickly use a method that we know in solving them. Let's quickly solve that. All right, so let's try to solve it. If I solve this, what's going to happen here is here my again differential equation is I'm in my step 4, right? I'm in my step 4. Here my p of x is equal to negative 1 over x and q of x is equal to 6x. No problem. So I'm going to use the previous method. So let's try to find the, step 1 is to, I'm keeping as step 1, so I'm going to call this step, 4.3, right? So here the integrating factor is going to be e to the negative integral of 1 over x dx, which is going to be e to the negative ln of x, which is going to be 1 over x. No problem. And then what I'm going to have is my solution, right? This is step 4.4, the 4.3 corresponds to the third step from the previous section. So what I'm going to have is the solution is going to be not y, u times 1 over x, right? Should be equal to, right? Should be equal to integral of 6x times 1 over x dx, right? That's what we have. And if we simplify this, this is going to be an x and x gets cancelled. So I have a 6 here. Then this is going to be 6x. Then I'm going to have a plus c is going to be equal to u times 1 over x. So this tells me that, u is equal to 6x squared plus c, right? So where we are in that step, if you take a look at this, we are right here. We found the solution u in terms of x, as you see there, right? We found the solution u in terms of x. We are right here. And again, in this step, we are right here. We found the solution, right? Now we have to do resubstitution and get back to our y of x. That is the idea there. So we need to do this process right there. If I do that process right there, what I'm going to have is, I am going to have, which I call step number 5. Let's go back to our regular color. Step number 5. Then, or I should say, I should use the blue. If we go back to step number 5, then u is equal to, as you see here, u is equal to negative y to the negative 1. If I do that, then this is going to be y to the negative 1 negative is equal to 6x squared plus c. And now I have to solve for y. So this is actually 1 over y is equal to negative 6x squared plus c. And if I solve for y, let me shrink it so that we can fit everything in here. So if I simplify that, what I'm going to have is I'm going to have y is equal to negative 1 over 6x squared plus c, right? And that's the solution to that Bernoulli's differential equation. So that's how we would solve Bernoulli differential equation. Again, the idea is a substitution, and that's what we're gonna keep on do that and then work with that. That's pretty much is the Bernoulli's method. Again, I recommend you to review. This is the homework number worksheet or homework number, this is the worksheet or homework number 4. So sorry, 3. So review worksheet or homework number 4 on your canvas. Again, there are more problems in there, you can do them. I will stop it right here, and I will, in the next section, we will talk about the exact differential equation, not different equation, it's exact differential equations. We'll talk about the next